Hi, this is Andrew, working on homework assignments in probability tonight. I have a probability distribution exercise that I need to solve, and it has 10 data points. I don't use a spreadsheet. I found this program online called cram101.com, which is kind of neat because it formats everything for you and gives you the formulas. It saves you a lot of time instead of messing with spreadsheets. So here's the Stats Lab menu on Cram. We need probability distribution. We'll scroll down here. There we are, probability distribution. And the first thing it asks us is the number of data points in the distribution. For my assignment, I have 10, so I put in 10, and then we need to put in the values. So the first one is 10, and then 45, 54, 16, 35, 29, 76, 78, 21, and 1. All right, let's just check our values real quickly, make sure I didn't make a typo. Good. If you want, you can always come back to Cram 101. They have this random data function, which it'll fill this in for you with random numbers so you can drill and practice till you kind of master the concepts. They also have a fixed data piece, which is an example that they've pre-worked out for you. Kind of helps learn the steps. Anyway, let's finish our homework here. First step we want to do then is to order the data numerically. So putting it in numerical order, we have this table now, which has 1 through 78. Good. Then we need to choose a number of intervals or classes for the distribution. What we're going to do is reduce the number of data points, 10, down to a more meaningful number, something easier to describe. We'll just take 5. Okay. So the upper level of our distribution is 78. The lower limit is 1. And that gets us a range of 77, which is simply 1 from 78. To get to the interval size, we basically take the range of the distribution, 77, and divide it by 5 and round it up. That gives us an interval size of 16. Sometimes we call that the interval width. And here's our interval. You can see that for each interval, the lower limit of that interval and the upper limit of that interval has been reduced by 0.5. And that's to ensure that every score in the distribution only fits in one of these buckets. That's important so you don't have any overlap in the second count. Okay, so the next thing we're going to do is get the frequency. So we want to find out how many scores we have that will actually fit in the interval. They have 3. Let's just check it out. So from 0.5 to 16.5, our first 3 values, yes, they fit. The fourth one does not. So that looks good. So our frequencies are 3, 2, 2, 1, 2 in the different intervals. Now we calculate the probabilities. So probability in this case is basically what's the probability of getting a score in this interval relative to the whole distribution. So we have 0.3 is our probability because we've taken the frequency of 3 divided by the number of possible outcomes, which is 10. So it's 0.3 or 30%. And you do that for each of the intervals. Now what's kind of fun, before we print that out, plot that out, is you can kind of toy with this by changing the number of interval sizes. So if you put it down to 2, for example, you're going to then have 6 possible in the first interval and 4 in the other. So you have a probability of 60% and a probability of 40%. So you can kind of toy with the notion of changing interval size and what does that actually mean to you. Okay. As I said, we can plot these out, so we can do a histogram if you like, and get a nice probability distribution, or you can do a polygon, which is a little more typical. And that's how you do a probability distribution. Thank you.